Hello, hello, hello. Sorry, technical difficulties. The capture card's not working with the laptop, so I'm going to stream without the presentation online, but I'll still be seen and heard, but you guys will be able to see what's on the screen. Still having issues with the resolution, but I'm just moving on at this point. So apologize. Thank you very much. How's everybody doing tonight?
Good. Good.
Excellent. All right. So if you are new to MySec, we meet 3 different times at 3 different locations throughout the state of Michigan. MySec Jackson meets the second Tuesday of the month. MySec Lansing meets the second Wednesday of the month. MySec Southfield meets the second Thursday of the month, which is today, obviously. If you're interested, there's also meetings for ISC Squared, North Oakland ISSA, Motor City, and Lansing ISSA. I have the information. If you'd like it, I can email you my notes, and you can attend those meetings as well. So be part of MySec. If you have a topic or a talk or even a lightning talk that you would like to see, let me know, and I'll see if I can find a resource who can talk about that particular topic. If you have a topic that you would like to share, by all means, please let me know. We would love to get you scheduled. You can start off as a lightning talk. This is going to be my first talk on Norvin, so it's a great way to break into just kind of sharing knowledge about things that you like in security. And actually, Dave and I are actually talking as well. It doesn't have to be about security. It could be something that you're passionate about. So it could be anything, so just let me know. Announcements. Oh, not done with that. So join IRC and Slack. If you haven't joined already, go to mysec.us. There are links there to sign up for Slack and also the link to IRC. There's a recent vote out there about what people prefer. It seems to be Slack at this point. I think I heard there was over 200 people on Slack. It's kind of difficult to keep up with, but there's different channels for different things. CTFs, if you're into programming, whatever it is, you can meet somebody online that you can share some cool information about.
You can turn notifications off.
Yes.
People have told me, I joined the Slack and my phone keeps going, well, come on, turn off the notifications. Sure, it's very active, which is nice sometimes.
Very active. It's hard to keep up with sometimes. Okay. Announcements. If you haven't heard of DCon, DCon is a North Oakland chapter and Baker College having a con, which is tomorrow and Saturday. It's at Baker College, Auburn Hills. If you would like the link, I have that. It's only $10 a day. There's some good speakers there. If you don't have anything going on, by all means, stop on by. Converge Detroit is May 10th and May 11th, and B-Sides is May 12th. So that's next month. So that's next month, the second Thursday, which is the same time we meet here. So we will not be meeting next month. So don't come here, no one will be here. We're all going to be in Detroit having a good time, probably at this time at a bar somewhere.
So come instead to Converge?
Yes, come to Converge.
Tickets still on sale? They're assuming tickets available?
And spread the word. So I'm going to post that on the website as well that there's no meeting. So if you have a friend, make sure they know. Social events. We're going to the Jolly Pumpkin on Thursday the 26th at 6 p.m. We've been going there regularly now. I think we had a turnout around 10 people last time. It was a good time. So if you wanting to socialize a little bit more and this isn't quite enough, by all means come on out. So today we have 2 talks. I'm doing a lightning talk on Norvin, and then we're going to have some a little bit signature writing with ClamAV and Yara in a little bit. Is there any other announcements that anybody would like to make? No. All right. Well, without further ado, I will move forward. Again, to those that are online watching or going to watch this a little bit later, I do apologize. All right, so using Norvin Sandbox. Has anybody here heard of Norvin? I did not. I was doing a little bit of research on the 2015 GERCON Forensics Challenge. Someone did a write-up on it. I was going through it. They referred to this as one of the tools they used to analyze some malware that they ran across. And I was like, what is this fine, cool tool? And it took me a little bit of time, and I actually realized how really awesome it was and how easy it was to use. So first thing, the topics I'm going to cover today is what is Norvin, why use it. You know, we use public sandboxes out there like Hybrid Analysis, Joe Sandbox, and also you can set up Cuckoo locally. Also, how to install it, how to configure, and then just a real brief demo and demonstration of what the output looks like from it. So a little bit about me. My name is Brett Hansen. I'm the Southfield coordinator here. Here's my Twitter and LinkedIn. I'll have it at the very last slide as well if you want to reach out to me. I have 2 sons. My youngest is now 8 months old, who's absolutely wonderful to work with. And I work at a local healthcare company as a SOC support engineer and analyst. and I've been doing security for about 4 years. So one of the things that I realize as I keep on learning and doing things is that I don't know anything. I won't claim that I'm a subject matter expert on anything. I'm kind of more of a jack of all trades. I dabble in this, I dabble in that. So don't think that I know everything about Noriben. I've just been playing around with it, and I just want to share it with everybody. So what is Noriben? Noriben is a Python-based script that works in conjunction with sysinternals and procmon to automatically collect and analyze events that happen on a workstation, virtual machine. It gathers that data. It uses a series of whitelists to filter out the noise that normally occurs on a Windows system and provides you an output of the things that occurred on the system itself. And we'll obviously give a demonstration of that. And it was written by Brian Baskin, and he came up with a name. He's a fan of bento boxes, which is like a Japanese lunch. Very simple. He chose the name because it's a very simple sandbox. It's very portable and easy to use. All right, so why use it? It's free. It's easy to set up. It's mobile, so if you're on a workstation, if you have a VM, all you have to do is download from his GitHub the Python script and procmon, and you're ready to go. You can also interact with malware. So if you're trying to debug some malware that has anti-sandboxing evasion, and you're launching that and it's failing, Norvin's a good alternative to that. You can launch the malware, you can use a debugger, you can skip over any code that may be going on that's detecting that anti-sandboxing. You can also, if you extract files from malware, there's command line switches to a lot of malware that's out there. This allows you to run the malware at the command line rather than just automatically through an automated sandbox. You also have unlimited time. So there's some ransomware out there and other pieces of malware that have a long sleep on them. You can launch the malware, let it sit on your machine, and run for days if you'd like to, and it's going to track everything that's going on. So even if there was malware that created a backdoor, then an attacker started coming into your system, you wanted it to sit there, this is a good option. Some other use cases that I thought of while using it, it's great for endpoint detection response content. So we developed carbon black content, and there's different things that we're trying to figure out exactly what happens when malware executes on an endpoint. When I started using this tool and seeing the output, I realized rather than having a complicated lab and detection lab with all the types of SIMs and carbon black running, you can use this to figure out exactly what's happening. It creates a great timeline and, like I said, lets you know every single file that it writes, every registry that it modified. It's also fantastic to use for troubleshooting an endpoint. So as an administrator, I've used procmon in the past to try to narrow down what's going on with software, but there's so much noise of everything that's going on. This script helps filter out that noise so you can actually get to what's really changing on the system. All right, so how to install? It's literally just a few steps. You could take a virtual machine, hardline box, anything, and all you have to do is install Python, download Noriben, and install procmon. Throw that into the same directory, and you're ready to go. And I will show that real quick. So I put it into C drive, Noriben, downloaded the zip file from GitHub, unzipped it. This is exactly how it came out. I threw procmon, and that was it. Well, I installed Python as well first, but that was the configuration. After that, you just run the Python script, and you're ready to go. All right, to configure it, you can do a lot of different things to configure the whitelist. There is the Noriben PY, which is the main application. I'll demonstrate this in a moment, but there's two main ways that you can whitelist events that are happening on your endpoint. You can do it by a file hash, or you can do by regular expression. The author was really good. He actually broke down different sections for the regular expressions, so you can whitelist things from the command line, from the registry, from the network connections. You also have the ability to use Yara signatures and connect it to a VirusTotal API. So if you have an API key for every hash that it detects, it'll go up to VirusTotal, check to find out what the rating is, 5 out of 50, 6 out of 50, and then come back and put that as an artifact in your report. There's also several command line options. It's a little bit better to see over here. So if you do the Noriben-py-help, there's all your switches. There's your first help that I'm displaying here. You can reanalyze things that you've processed in the past. you can apply different filters. But right here, you just specify a hash and a path to the whitelist of hashes that you have. So if you created a known good list of all your endpoint hashes, you could point that right to it, and it's going to eliminate all that as potential noise. You can also specify what type of hash that you're going to use. You can set the timeout. So if you want it to automatically time out after 2 minutes, 2 hours, 2 days. You can specify your output directory, your Yara signature directory, and the generalized just gives it for its relative path rather than the full path, which is done by the default. You can also pass it the actual command line you want it to execute when Norvin runs. Any questions so far? All right, so brace yourself, live demo. So real quick, I should have left this open. Hopefully this opens up where I left off. Yep. So I'm going to go back up to the top, but this left off right where the some whitelists I was working on. So one of the things with Windows 10 that I found very frustrating is you can disable updates, but it still goes out and checks for updates. You can disable antivirus, and it re-enables antivirus. It's been very frustrating, but it's been a good learning experience. So here's some Windows IPs that it goes out for MSN as well as Windows Update. So I started to whitelist those to clean up some of the noise I was seeing. So the configuration files. The author has done a really good job documenting everything in the script itself. There is a configuration section right here. He outlines it. You specify the path to procmon. I just put it in the same directory as the shell script. You can specify your VirusTotal API key. You can specify a folder for your Yara roles, and you can specify what kind of hash that you want. So the exact same type of things you have at the command line, you also have within the script itself. Then there's some rules about writing your regular expression for whitelisting. There is a global whitelist that just covers everything that it sees. Then you can specifically specify, hey, if I see anything on the command line, I don't want to see it. So you specify the command line, you have a file whitelist, a registry whitelist, your net connections, and then your hash list that you can actually update right inside the file itself. So I'm going to do a quick little demo. First thing I'm going to do is I'm just going to launch calc and kind of demonstrate what it looks like when it outputs the report. I've had some issues with some of the malware I've been executing. Not quite sure why, but we're going to give them both a try. First launching calc, then actually trying to look at a piece of malware. So you can see it launched procmon, and then it tells you just go ahead and do what you need to do. When you're all done, just hit Control-C. So I'm going to launch calc from the keyboard. Launches it. I'm going to close it. And hit Control-C. It's going to close procmon. Procmon creates this large database of everything that occurred on the system. It's going to go through that whitelist that I just showed you in the Python script, and then it's going to spit out a text file of all the events that occurred. Hopefully. It usually doesn't take this long. There we go. Can everyone see that? Yeah, that looks pretty good. So a little bit of information at the top. Here's all your processes that were created. So it noticed that Explorer launched calc. I also launched some services. And then you can see all the file activity. So calculator created a file. Gives you the SHA-256, so that's what is configured. Let you know any of the registry activity that occurred. And then any network traffic. And we know calc doesn't communicate, so there's still a lot of noise that I have to filter out. There's actually quite a bit there. That's interesting. And those are all Windows Updates IP, so it's really, really interesting. All right. Oop. So I'm going to go ahead and I'm going to restore this back. Actually, I'm going to launch it from right here and see what happens. So when this report gets done, it throws it into the Norvin directory. And you can see it's dated right there. The file we were just looking at was this .txt. There's also a timeline.csv. You can see, oh yeah, I got to register that, right? Who does that, right? So it gives a perfect timeline of everything, network connections, file connections. So one of the ideas I've had in the future is taking this, throwing it into Splunk, and then correlating some of the key events between these different pieces of malware that we may analyze. Questions? No. So let's do this again. Let's actually try a piece of malware. Can't be too safe, right? I actually grabbed a document that came into our environment a couple weeks ago. At the time, there were no signatures. There are now.
Okay.
Yep. Just commodity stuff that comes in the front door all the time. So I'm getting this set up before I actually executed the Python script. And this is one that I've had kind of mixed results on, so we'll see what happens here. All right. And we know the first thing we always do when we open up a Word document is enable content, especially if we don't know where it came from, right?
Yes.
Just checking. One of the things I found interesting, though, is the image disappears, and once the malware gets done executing, the image reappears. I don't know if that's common or not, but I'm going to let it sit there just for a second to make sure it's doing whatever it's doing. I'm going to terminate it. Now, when I actually process malware, I've noticed it takes a time for it to process through that database and provide a text file output. So while that's running in the background, we'll come back and take a look at it. But I actually have one from earlier, and I was playing around with WannaCry and a couple other pieces of malware that I was able to get my hands on. And this is when I was playing around with the filtering, and here's a report. All the way up. It's got a really good summary right at the top. Word executed. It launched a command prompt with PowerShell, and there's all your commands that were executing for that piece of malware. Oh, all the time. And PowerShell right afterwards, right. So here's your command prompt. It's trying to make a connection. And then your full PowerShell just kind of takes off, having a lot of fun with the system. File activity. So there's some things going on with Explorer, WinWord. Now it's creating a temp file, which got deleted. That's why I wasn't able to create the MD5 or the SHA-256. And there's some noise there, but then we get into the good stuff where PowerShell launches. And then you got your actual scripts that are executing. And of course, after it executed, it got rid of that file. So this is where I was actually talking to Dan. If you have a debugger running and these files get deleted and you want to analyze them, you can use the debugger, stop the malware, grab that file so you can analyze it further. So that's another use case of why this would be a good sandbox tool. And of course, you know, anything running to local app data temp is always a lot of fun. A lot of PowerShell goodness going on.
Now, so you've got a lot of different processes running at the same time as malware is executing, and you're stepping through, and so your whitelist also whitelists what you step through?
Yes. So if you wanted to, so you wouldn't see your debugging tool, then you just throw that into the regular expression in that Python script, and you just wouldn't see that in the output. So getting down to the bottom here, and then we'll go look back to see if it finished. The netcons, it lets you know what was actually connecting out to the internet. So that's Windows probably trying to register itself. Here's PowerShell making the connection out, and it coming back in. And then PowerShell making a second connection out. And if we take a look at this piece of malware out on VirusTotal or Hybrid Analysis, these are two artifacts that show up as a primary indicator. So you can use this if you don't want to upload to a public sandbox, you may not have Cuckoo set up. You can throw a Python script, procmon, execute it, find your IOCs, now you know what to go look for in your environment. So I thought this was pretty cool. Yes?
Did you just activate this?
I did. Yeah, if you look it up on VirusTotal, it's associated to several websites. Oh, that's why I have 2 of them running.
You didn't copy the first 2.
I didn't?
No.
Are you sure?
Oh. 2 at the beginning.
Well, that's got it.
No, it's 202.
202, thank you. You can see down here, there's a lot of URLs that have been associated to the IP. Okay. Any other questions? Yes?
Sorry if this, you said this already. How much of that configuration of the web list in it is already there? Did you have to write a lot of it, or most of it was there?
The only thing I added to that whitelist were 4 IPs.
Okay,
The rest of it there, if you go to the author's GitHub page, he actually asks users to go out to different systems, run calc, and then take the output and upload it to him so he can keep on building that whitelist to make it better and better and better. So that's all I had to do was add those couple IPs to reduce a lot of the noise. There's some noise there from Windows trying to update, Word trying to update. I would like to get those added to it so I see less noise, but most of that was all about the malware executing. Anything else? Thank you.
Very good.
All right, so next we have Dan, and I'm going to try to get the capture card back
I
into
have some
place.
advice for you. Would you like to hear the advice?
Sure.
The advice is that you should unplug the capture card and then remove and re-add the device in OBS. Does that mean something to you?
It does, but yours was working, so hopefully yours will just work.
So it's, hold on a second, so you're the problem here?
That's never been the case.
Sure.
All right,
Hi neighbors, hi. I'm ready to do this. I got my little note card, I'm ready to go. I feel so prepared. Shame that didn't go. We'll figure it out.
Yep. Well, hopefully yours will screen.
Computers, how do they work? They're so difficult. Oh man, let's see if I can sort of see everyone. I don't like being not being able to stand up. Alright, so what are we doing? Are we doing this? Yeah, Kyle's saying it's okay. Oh man, computers.
There we go.
Is it,
It's looking fantastic.
Is it working?
It's not on screen yet.
it's not on the screen yet? That seems like an issue. It seems like it's working. Maybe. Maybe it's working. Oh man, I got my little, look at this, I got my little notes. Are we ready? Is it working out?
Looks good.
Oh no, we can't see nothing. Hold on a second. What's happening here? How do I do this? Oh, there it is. Look at this. How about? No, that's terrible. Huh? Maybe? A little better? Oh, it's already on 1. Is that, can you even read any of this stuff? Is that a little better? Can you read it now? Okay, that's good. Alright, so hi everybody, hello neighbors, hello security friends. It's my first time in MySec Southfield, it's amazing, I love it. It's so good. Alright. Yeah, exactly. So, I want to talk today a little bit about AV, and Brett asked me to talk about AV. He was talking about a sandbox thing, like the other part of dealing with malware is antivirus, right? Maybe, sort of, kinda. Does anyone like AV, maybe? Do you like AV, Brett?
Best endpoint protection on it.
Okay, if you say so. So today I want to talk a little bit about writing AV signatures, which sounds a little weird and complicated, right? How can you write AV signatures when all the AVs are closed source and proprietary? Well, that's true. A lot of the AVs are closed source and proprietary. A lot of the antivirus software that you can install on your machine, you can't do anything with it, right? If you have a new sample that is pretty new and there's no signature for it yet, most of the time you're screwed. Sure, maybe you can submit to the vendor your sample, and maybe they'll get back to you in a week or 7 or something, and they'll provide you protection for this thing that you just found in your environment today that is running and that you would like to do something about. That would be nice. But where the traditional AV fails, we can, as analysts, write our own signatures. Now it's kind of useful, but it's not a panacea, right? The best thing to do is to have a complete security solution, which includes AV and includes EDR and includes all of these other things. And Procmon's great, to Brett's point, right? If you have good filtering so that you can filter out the fire hose. I wish you would, maybe we can see later, we can see the fire hose of data that Procmon shows you before Noriben comes and filters it all. It's kind of a nightmare. So I want to talk about ClamAV. ClamAV is a little bit different. Clam is an old, I don't know how old it is actually. It's an older antivirus. It is open source. The code for the engine is on GitHub. Long time ago, the rights to Clam were acquired by SourceFire, and then when SourceFire was acquired by Cisco, Clam became a Cisco product, if you will. But Cisco have continued to support it. They've continued to advance. They've continued to make changes to it. It is a current maintained antivirus, and it is still free. There are commercial offerings that include it. Are we good? Are we streaming? Sweet. But Clam is nice because it's open source, and so is the signature format. You can write your own signatures. It's great. So if you are using ClamAV, you can write a signature for your crazy malware that you just found, and you don't have to wait 2 weeks. Of course, you have to write a signature, but it's not as hard as it sounds, right? Well, don't worry, we'll get there. It'll be fine. There are a couple of caveats, though. Clam is not a complete sort of antivirus product like maybe Windows Defender is. It does not have an on-access scanner. It does not have a resident scanner component to it. It is only sort of an offline, you scan this file when I tell you to scan this file type situation. It doesn't have any heuristics detections, right? Antivirus works partially on signatures, on files, but then partially on heuristic data. It tries to, it looks at the behavior of a piece of software, and it tries to classify good and bad based on what a program is doing while it is running in some cases. So if it doesn't have a signature for a file to say when it's on disk this is bad, maybe when it's running it'll decide, wait a second, no, this is whatever the hell you just did with PowerShell up there, don't like it, and then it'll kill it, hopefully. I'm going to get my glass real quick. So Clam is a little more limited, but it is still very widely used. Clam is used in a lot of these offline type situations, particularly on mail gateways, right? So if you have a mail server, you can stick Clam in the pathway of your mail to have it scan all the attachments, have it scan the body, and have it scan a bunch of stuff, and then only forward the mail if it decides that it is clean, or maybe strip out the attachments, something like that. I've also seen it used on proxy gateway devices, stuff like that, to stop your users from downloading stuff that is bad, no matter the state of their antivirus on their box, right? So it still has its utility, even though it is not like a Windows Defender or like a Sophos, whatever the hell you've got. Does anyone have any questions so far? Does anyone know about Clam? I'm sure people do. ClamAV?
C-L-A-M.
C-L-A-M-A-V, yes. And it is free. It's on all the operating systems too, which is really nice. It's on a bunch of different operating systems. I think there might be an IRIX port. It's very crazy. But you can download it, you can run it. So yeah, I guess that's kind of the only thing that I wanted to talk about, so let's just get into it. So if you're in a corporate environment, maybe you've got Clam on your mail gateway and you get some weird thing in a phishing email, you get a weird attachment and it's not detected by your antivirus, so you get a copy of it, like Brett did, and he ran it through Noriben and he found a bunch of stuff. But how would you go about writing an antivirus signature? What the hell is an antivirus signature, right? So here's the secret. There's no big secret. Antivirus is just a pattern matching engine, right? It just matches patterns of bytes. And you can get complicated. You can do crazy stuff, like Clam does, and we will see shortly. But it is just matching patterns. And you can go crazy. You can make crazy regexes. Clam is really nice in that it understands a lot of different formats, so it will decompress zip files, and it will decompress ACE archives, and it will try to unpack packed malware and run its rules on the inner sample instead of the outer file, stuff like that. So we've got a lot of power right here that we wouldn't necessarily just get if we were to scan, like, I guess we'll talk about Yara in a minute. You touched on Yara, right? Did you want to introduce Yara a little bit? I noticed that it said something about Yara. What's Yara?
Yara is a open source format of writing signatures that can detect malware or other types of running systems. Yeah,
pretty much. Yara is very much like a cut down AV. It's a pattern matching tool, right? It is a program that takes a set of rules that you give it and some files to scan, and it will tell you whether the file matches the rules, which is essentially what AV is doing. It's not quite as good as ClamAV. It does not, for example, unzip zip files. It doesn't try to unpack malware. It doesn't try to do anything crazy. It just scans the file you give it. But Clam can also use Yara rules, which is gives you some really nice flexibility. Because sure, you can write Clam signatures, but if you have those signatures in Yara format too, or if you already have a bunch of Yara rules that you don't necessarily want to convert, you can give them to Clam, and sure, you can use Yara to scan with these rules, but you can give it to Clam and it will unzip zip files and run your Yara rules on all of the files inside your zip file, for example. Stuff like that too. So it's kind of nice. So I would like to stumble through some very generic building blocks of making a signature. I'm just going to shut up and get to the goddamn point. So we're going to start simple. The simplest kind of rule that Clam can deal with is a hash rule. which is the hash of a file. If it sees this file, it matches the rule. If it sees a file with this hash, it matches the rule. So, for example, if you've got like a web gateway and you get something, you get this picture right here, and you decide that you want to make sure this picture never makes it across your goddamn wire because it's terrible. I mean, look at this; it's a nightmare. But this antivirus doesn't get detected by this, or antivirus doesn't detect this, which is bad, right? So we can. It's easy to scan a file. Let's just scan a file. Clam scan. This. Oh boy, this is going to take forever now. I didn't pray to the demo gods. Curses. So it's doing a lot of stuff here. Maybe I'll just let that. I'll just let that go and come back to it later. Oh no, it finished. That's good. Okay. Oh no, computers. How do they work? Okay, so I guess it decided this was fine. I disagree. The system administrator disagrees. I do not. I know. I'm not. I'm just going to put that to one side. Whoa, no. What have I done? Oh God. Let's just keep that right there. Just you can look at us for a minute. Okay. Perfect. This is wonderful. So how the hell do I write a rule based on this? So if this is an image, let's just hash it. Why not? Let's just make a real simple rule and then we'll look at it. So Clam comes with a tool called Sig tool, which is a little tool that helps you write these signatures. It is like a little Swiss Army knife for things that you might want to do. And one of those things is you can give it a file and it will compute a hash and emit a ClamAV rule perfectly formatted. So let's just try doing that. Sig tool. So I've got my little syntax right here because I can't remember how these formats work. So you can tell Sig tool to compute a hash. You give it this thing, and let's see what it does. All right, so it just emitted on the command line the file name, I think, first, or the file name's in there, but the hash first and the file name. And I think that's the length in there, but this isn't very useful. We wanted to put this into a file, right? So we have to make a signature, and we have to give it a particular file name, or it won't work. So now, well, let's have a look at this first, right? Okay, so we see that this did a bunch of crazy stuff. Yeah, so we've got the file hash, we've got, I think that might be the length, and we've got, this is the name of the file, but this is the name of the virus that Clam is going to show. So let's rename this bad malware definitely. Okay, all right, sweet. So now if we do this, we can Clam scan and we can give it a signature database, and then we can tell it to scan our file. And this time, hopefully, we can see right here, we've got a file name and we've got, let's just make this bigger, how about that? So we can see this a little more clearly. Oh, I've lost everything now. So right here, it gave us the file name and then it said found, which is bad, right? It would say okay if the file was okay, like it did up here, right? Where it said this JPEG was okay. Now it says it's got the name of the threat and it's found, and it just gives you a little thing. Known virus is 1 because we gave it a database with 1 signature in it. We scanned the file, we found an infected file. So now if I set my web proxy up correctly, this file, this terrible file, will not cross my network again because Clam will find it and it will say no. I feel good. Don't you feel good? No? Wait, stop cheering. This is scrappy. This is a file hash, right? If I change 1 bit in this file, which to be honest I could probably do with this JPEG and it would probably still display, it's not going to match anymore, right? We just hash the file. So can we do a little bit better? Probably. So we can match on bytes, right? So the challenge here is we want to make it general enough that we'll catch a class of malware and not make it effective only on 1 file, like that would be like the hash signature, right? But we don't want to make it specific enough that it will only trigger on this 1 file. So I'm thinking about this. I think that you guys get this, so I'm not gonna. We won't do this example with this picture again. Let's have a look. What else we got in here? All right, so we got some executables. Let's have a look at this one exe, shall we? See what we've got. So let's move on. Loop, loop, loop. I can't remember what this is. Oh god, that's tiny. Oh god. Oh boy. Let's make this a little bigger, shall we? Oh boy. Oh no, everything's bad. All right, what did we decide was good? 24. It's as big as it goes, guys. All right. Oh god, this is huge. Can you see that? Can they go smaller? I don't know. You think so?
I got new glasses, so.
How's that? Good. Close enough? All right, sweet. So, oh boy, we've gone somewhere else. That's bad. All right, so this is a new sample. This is one of the ones that Brett showed, I think. So if we've got a piece of malware, some code, this is where we might be able to start making some. We might start applying our brain a little bit and trying to write a good signature. So I know that I want to find a pattern of bytes that will be specific to the sample, but maybe not so specific that it will just be like a file hash, right? So we can just look through, I don't know, what the hell's happening here? This is boring. Let's just look at the strings. That's what cool people do, right? What strings we got in here? Nothing? Seriously? Oh, wait a second. Wait a second. Hold up. What the hell's that? Can you see that?
No.
Good. I can't either. Okay, so let's go back one. So this right here, this looks like a command, right? VSS admin delete shadows /all/quiet. That's not good. So I think that I found a pattern of bytes that I'd kind of like to write a clam signature for. It's not so general that it will only catch this one sample, and it's not so specific that it will only catch this one sample. And it's pretty general. This will actually probably fit a bunch of different malware families, right? Anything that tries to delete the shadow copies using the volume shadow copy admin tool, that seems like something I probably want to alert on. So what we can do is we can just copy these bytes right here. We can just copy these bytes. Now the only annoying thing, you got it right? Yeah. Oh god, hold on a second. Don't want to run anything. So the only bump in the road here is that when we write a clam signature with these bytes that I just pulled out of this executable, they were just lying there, right? They're not packed, they're not obfuscated, they're just sitting there, so clam should be able to find it. We have to convert them to hex format because that is the format that, that clam needs. But SIGTool to the rescue again. SIGTool can convert, you can do this a million ways, right? You can convert that string into hex if you want to, any way. But let's try and do this with, oh, how do I do this? Let's read the man page. How about that? Does it have a man page? Yeah, it does. Hex dump, there it is. All right, so if I do this and then press enter, it should emit a bunch of hex bytes, right? That's what I want. That's what I need for my signature. So let's do that again, but stick it into a file like one, because this was called 1.exe. This is going to be a byte, a nibble signature, right? NDB. What am I doing? NDB. Sure, I got it right. Look, I wrote it down. So let's paste that in. Let's press enter. Let's press thing. Let's go in here. So let's start building our signature. Now, I've already made a mistake, right? I have that new line at the end, the 0A. I don't want that. That's bad. All right, so the way that we form this signature is very, very similar. First of all, well, it's similar, but it's kind of backwards. So the first thing in the format for this kind of signature is the name. So let's call it bad malware. And then we delimit this with a colon. And the next field describes the kind of file that we want to match against. Clam, you have to tell Clam what sort of file you want to match on when you do a byte-based signature, a string-based signature. And it can recognize a bunch of different formats. In this case, this is a portable executable for Windows, so we want to use the type 1. And again, this is all in the documentation. I'm not going to read the documentation in front of you because it's boring. You can figure it out. The next thing, we can specify the offset in the file that we want to look for. So if we know what the file starts with, we could maybe give the offset as 0. But here, it could be anywhere, right? I don't know. I didn't check. And then we've got our bytes, and I think that might be it. And if we've done this right, maybe, we can say 1, and then we can scan our 1.exe. And it should say that it has found a thing. It found bad malware. Oh no, our signature worked. Yay. But it's kind of interesting, right? So we just went into an executable and found a string. This could equally be a different byte string, right? And you can do crazy stuff. You can specify multiple byte strings. You can specify wildcards in there, so you can put in question marks and things like that, and say, hey, match on these bytes, and then any bytes for 8 bytes, and then these other specific bytes. In this case, it was super dumb, but I'm just trying to show you what tools you have, right? The other thing right here is I kind of wanted to show you some of the limitations. I'm trying to remember which one I want to look at next, and I think it's probably this one. So let's get out of that. Let's not save this thing. So this one's kind of good. Sure, do this. Do all the things. No, that's not good. We've got error error messages, man. You just click through them. I'm telling you. It's fine. But this doesn't look good. We have no functions right here. What if we go to strings? I bet there's not a whole. Oh my god. What have I done? We did get some stuff. We put the strings window over there. That's terrible. We haven't got very many strings, right? This is kind of shitty. Okay, let's have a look here. Let's go to the entry point. Where are we going? Start, pull, jump. That goes there, that goes there. Blah, 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 blah. Where's this going? Down here. That's fine. That's not good. We've got a reference to a place that it doesn't know. I'm seeing some red stuff, and I'm seeing a bunch of garbage. This is kind of crappy. I don't want this. What the hell, man? So this sample looks like it's packed to me. We could write a signature based on this, but because it's compressed, it's packed, we will either make a signature that will not work if it was repacked or packed with a different packer, or we will make a signature that will alert on everything that is packed with this particular packer. I've seen plenty of plenty of fine antivirus products that I may or may not have spent a bunch of money on, that if you use a packer to compress like notepad.exe, it'll go crazy. It'll say, hey, what have you done? This is malware. When in reality, oh god, let's just avoid that. When in reality, we know that it is fine. If I double click on this packed file that I just packed with a packer, it runs Notepad, it's fine. So I don't want to make a signature based on this. So this is where we would get up the debugger, and I would wave my magic wand and say, here's one I made earlier. So wait a second, but maybe we don't have to do that, because I saw an interesting telltale thing right here. I see this UPX section name. I know that UPX is the name of a packing tool, right? A tool that is used to compress executables. It looks a bit weird, though. I don't see, like, the code, the decompression program does not look like the normal UPX decompression program. But nevertheless, we can try. UPX is really cool in that they provide you a tool to decompress a UPX packed executable. So we have a little bit of evidence right here that this might be packed with a tool called UPX. So let's try, hold on a second, how do we use UPX again? Let's look at the man page. Options, command options, how do I decompress? Decompress, where is it? Decompress, oh my god, you can decompress things with the -D switch. Okay, let's do that. -D 3.exe, do it. Okay, well that's, okay, not packed by UPX, despite the fact that it has the section name. Oh no, we have learned a rule that is not always true. So it looks like this thing is packed in some other way, but it is trying to fool us. Luckily, we can manually unpack things if we have big brains, which I didn't bring with me. I used it last night instead, and I unpacked this myself. So now we can look at the inner program. Oh no, now we've got more stuff, so I didn't fix anything. That's fine. So if we get to the end of this thing, now we have a little bit, we have the inner program, right? That we would want to write a signature on. So I'm in two minds about this, right? I know that Clam is kind of cool. I know that Clam can also unpack UPX packed executables, stuff that's compressed with that particular packer, and it will be able to scan the inner program. But I'm not sure. The UPX tool couldn't unpack this. So let's, I guess, see if we can do something. I don't know. So all I'm looking for is something specific, something in particular. These numbers look pretty crazy. Like this little, maybe this little sequence right here is something, a sequence of bytes that we could write a signature on and see if Clam can do it, maybe. So let me check something. Let me put this up a little bit so I can see the bytes that I want to copy, right? All right, so I have chosen just kind of arbitrarily, because this isn't super general. Maybe it is, I don't know. I'm going to choose from here, like this push instruction to maybe this next push instruction, right? So I want to get these bytes. Hold on a second, we can look at this next. So I want to get from this. Oh no, I made it all tiny. Oh no. How do I do this? Oh, computers, how do they work? So let's say I want to go from here to like the end of here, right? So I see that's this 68 to here. So let's just grab this whole section. And let's copy it. And let's do the same thing. Let's start making our signature, right? 3.ndb. Is that the name of this goddamn thing? Let's do this. All right, so we know, actually, let's cheat and open the last one. Because we know this is gonna be the same format, right? The same sort of stuff. We're gonna have the portable executable, the Windows format. We're gonna start wherever, no offset, but we're gonna get rid of that stuff. And instead, we're going to paste in our bytes. So let me have another quick look. So we've got from here, this little section right here, down to wherever the hell I said it was down to. 0, 90, is that too much? 68, down to where? Oh my god, I'm all confused now. Where did I say it was down? 68, 88, C, 811, 68, 88, C, 811. 0 to here. Okay, so I want to chop off some bits. Let's just chop off some bits. Let's get rid of this piece of crap. Don't want that. Let's chop off. Was it the rest of this? Sure, let's do that. Let's put these together. Let's put these together. Let's get rid of all of our goddamn spaces. Computers. All right. Bad mal. Oh, I got rid of the space in here. That's bad. Okay, worse. Unpacked. Unpacked mal. Well, you can put spaces in here. We don't care. Unpacked mal. Well, no. Maybe that'll break it. Let's find out. So, what I want is for this signature to match the first file, right? The packed version. Hopefully, Clam will be clever enough to decompress it, and we will get a hit. But maybe we won't. So, what do they call it? 3 something something something. Did I overwrite it? I meant to write it separately. Okay, that's fine. All right, so, oh boy. Okay, so we can see right here, I scanned all of the files in the directory by mistake. That's fine. So 3.exe, it said it was fine. That's a shame. These ones are actually IDA temporary files. Let's close IDA. Oh no, how do we do this?
What did it detect the unpacked file?
Well, we knew that it was going to detect the unpacked one, right? Because that's the one that we wrote the signature based on. So it looks like Clam is not infallible, right? Clam has its limitations. If this thing was actually packed with UPX, instead of just looking like it was, such that we could unpack it with the actual UPX tool probably, I reckon Clam would have got it, because Clam's pretty smart. But it's not a panacea, right? Just like normal antivirus, it's not going to do everything. So in this case, we extracted from this file. This is the file that we extracted those bytes from. We identified a little short passage of instructions that hopefully will catch the malware family and won't be too general to catch everything. And we see that it didn't catch these other executables, so obviously I chose OK, maybe. But of course it matched on that because that's the one that we made the thing on, right? So I just wanted to demonstrate that this is kind of how easy it is to write signatures. It's not super crazy. The format isn't particularly crazy, right? And this format is all documented online. There's pretty good documentation. You can do crazy stuff though. Like I said, you can have multiple byte strings that you can combine together. You can put wildcards in. You can have logical operators. So if we see this string or that string, you can just have it run regexes, right? You can just say, hey, run a regex on this. And it is smart enough. I don't think we've quite got time, but it is smart enough to go into Word documents and decompress the macros, right? Macros are stored as compressed streams within Word documents, Office documents. It will recognize those early objects and it will decompress them, and then on the text, the plain text macros, it will run your regex or your byte matching or whatever. So it's pretty good for looking in all the nooks and crannies and getting its flashlight out, right? Better than Yara would. Yara would just scan the file that you give it, which is why it's nice that it can take Yara rules. I'm not going to have time to show you a Yara rule running in Clam, but Yara rules are very similar. This byte string, for example, would work just fine in Yara. You just write a couple of extra lines, the syntax is different, and it will be able to use it. But that's why, because you can combine the Yara rules that you already have maybe with Clam's really cool decompression abilities. Does anyone have any questions? That's kind of all I got. I wanted to show that it was possible. Come on. Yes?
I think a little too much like Rube Goldberg occasionally, so I apologize for the crudency idiot.
No.
If you apply this to a proxy for outgoing messages.
For outgoing email messages.
Right.
Yep.
And you wrote a specific character or string that was part of, let's say, your company letterhead.
Yeah.
Could you use it to filter and prevent people from externally sending emails of inappropriate documentation, let's say corporate data?
Mm-hmm. That was a great question.
Annual report had it embedded in the
Yeah, I know, right?
right off of
So I'm going to repeat the question because the mic's right here. So the question was, could you use this on an outgoing email gateway device and maybe write a signature for your company letterhead or particularly sensitive company documents? You could use this, like write some signatures for your trade secrets and then prevent people from emailing out of the company things on the company letterhead, your annual financial reports, your trade secrets. And the answer is yes, you could. Are there better tools to do that? I don't know. I'm not an email administrator. I'm sure that all of the Exchange admins in the audience right now are going, well, wait, I could do that in like 5 seconds. Great, I'm sure you could. I can't. But yes, the answer is yes, you could indeed do that. And that's not a bad idea, right? This is why it's nice to be able to write signatures. And I just wanted to demystify it a little bit for you because people think it's creepy. And I kind of thought it was creepy too until last week. But it's interesting use cases like that is the reason that this is cool, right? Is the reason that this is powerful. You're never going to have in the antivirus database that gets pushed out via Clam updates every day. You're never going to have your company letterhead or your trade secrets or your financial reports. But yeah, you could do that, sure. I've seen other use cases that I've heard of is like in an educational environment, you don't want kids downloading certain programs or bringing them in on USB sticks or saving them in their network home drives. And if you can scan all that stuff with Clam, you can just write a signature for a legitimate installer for like games or like write a signature for the Steam installer, I don't care. Stuff like that. And then you can prevent people, assuming that you have the infrastructure in place, right? And like I said, Clam is easy to run. It runs on most operating systems. You can find that out online. Sure. Come to Brett.
Do you have any sense of the performance trade-offs? So, I mean, I assume that a wildcard in the offset is going to cause a big performance hit, whereas if you give it an offset, that's going to be a lot faster. That's an assumption, I think.
Yes, it is, yes. Disks are fast, CPUs are fast. If you just do one of these things, like I could put wildcards like in here, I think it might actually be like in Yara, I think it might be like question marks. This is going to slow it down for sure. If you give it an offset, it can open the file and it can read from that offset directly. Does it match? No, throw it away. Whereas if we give it the star, I have to read every goddamn byte string. But it's still pretty quick. It uses, I would hope that it uses clever algorithms so that it doesn't have to inspect every byte, much like grep would also not do that. It will also be smart about it and be quicker.
Have you had enough experience with it yet to have a sense of those? Or?
Yeah, the more complicated rules you give it, the slower it is, yes. And it depends how many files you're scanning too. Like if you put this on your web proxy and you're scanning every image that's coming over the wire, it's going to slow down the internet for your users. But for an email gateway, if you take like a second or so to scan every incoming attachment, it depends on your volume, right? Only you as the email admin could answer that question. It's probably worth it for AV. And how it compares to other antivirus engines, I'm not sure. But for sure, if you give it more complicated rules, if you give it regular expression rules, stuff like that, it will definitely be slower. But on one file in our situation right here, you wouldn't notice it, right? But sure, performance is absolutely, it comes into this, much like it would anywhere you see, like regular expressions being used or wildcards coming into it, any sort of sphere of computing where that's the case, it'll for sure slow down, yeah. Brett, you had a question?
Can you mix regex and the byte scanning that you're doing?
My understanding is that you can, but I'm not sure. It's a good question for research later. Yeah, the question, I'm sorry, I didn't repeat your question, I'll get to it. The question was, can you mix the byte rules and the regex rules? I think you can. I think the last signature format that we didn't get to is the logical signature format, and I believe that you can give it regexes or bytes. And the other signature format that we didn't go through just adds another section in here, and it sort of lets you concatenate things. So in your bunch of signatures that you would give it on the end, like the first, so you would express your logical pattern like, I want the first signature and the second signature, or the third signature, stuff like that. That's how it works. Yeah. Yeah. Any other questions? Is there anything I didn't do that I should have done that you're curious about?
Do you have time to touch on Yara? I mean, we got time here, but.
I guess, maybe. I'd have to look at the documentation and remember how to write a goddamn rule. It's not very interesting. That's the thing. We'd just be showing it doing the same thing, running a Yara rule. The point is that the useful thing, the reason that I bring up the Yara compatibility is because a lot of people already have a database of Yara rules that they like to use. And then, well, it'd be nice if you could, I don't want to have to put Yara on everything, but I've already got Clam on everything, maybe, you know. It's a bit of a niche situation, sure. And the other question that I had is, no, you can't use these signatures with Windows Defender, you can't use these signatures with any other things. Sorry. It sucks, but that's the way it is. I wish that other people would open source their signature formats and allow you to write them, and maybe they do, and I don't know about it. Yes.
So just to your example, I'm still trying to understand. Basically, you took a hash of something that you saw as malicious, and you're saying that Clam is looking for that hash all the time, always.
Oh, I see what you mean. So let's go back to this signature that I think I overwrote. Well, so not really. Not in the same sense that Windows Defender might. So Windows Defender sitting on your computer all the time, scanning everything that you access, scanning everything that runs, it's on access, right? Clam is strictly offline. It scans a file when you tell it to scan the file, and only the file that you tell it to scan. Sure, so you can do like a full scan with ClamAV, and you can download a Windows version of Clam and do that. And if you gave it your hash-based signature, that means that any file that you told it to, and if you told it to recursively go through your whole hard drive, it would, for every file on your hard drive, take the hash, compare it to the hash, and decide whether it's bad or not. But it doesn't, Clam is not a program that sits on your computer running all the time. You'll notice right here when we ran it, like I ran Clam scan, and it did it, and then it quit. It's not running right now. It's not it doesn't live on your computer all the time. You invoke it, you say, hey, Clam, use these rules, scan these files. It does it, and it goes, okay, here's the report. So that's that. Does that get to your question a little?
Well, sort of. So in regard to that, then the example of the kids downloading games, or the company letterhead,
right.
It would only identify that it was done, not preventing it.
This is 100% infrastructure. Have you put Clam in the way of your outgoing email, or have you not?
You're telling it to run every time an email goes out.
So if I'm an email administrator, I could use Clam on my mail server. I have decided that whenever I send an outgoing email, the first thing I do is this, the second thing I do is this, the third thing I do is scan it with ClamAV. And if Clam triggers on this email that is going out and it's on company letterhead and it matches your signature, you get to decide. You tell Exchange to drop it or whatever you want to do. So you have to put it in your infrastructure, yes.
Sure, yeah.
But you could, the sky's the limit, right? How much braining do you want to do around infrastructure?
I might add that it's transparent to most people who use the products. But like,
oh, for sure, yeah.
Proxy scanner,
yep.
That's actually what it does. It uses a scanning engine. So Symantec has the scan engine.
For sure, yeah.
Years ago.
Yep.
Same thing. So like, it feels like real-time protection on your web proxy. It's not. Every HTTP proxy is there. It goes, oh, you're downloading a file.
Yep.
Downloads it, puts it on the file system.
Yep.
Says scan this.
Precisely.
The result makes a decision and then sends it.
Yeah, you as the user sitting on your machine sending an email, you'd never notice, sure. But the send mail script in the background first scans the thing, then it sends it, right?
Yeah. Most any network web device you're putting in the way uses an engine like this.
Yeah, precisely.
Gotcha.
All right. Anything else?
One of the interesting things about being an open source signature is that there's actually a Linux signature set not only for IC Linux executables, but it's also for Windows as well. So one of the things I've done for this is actually run a Linux live, install the ClamAV on that live disk, and use it for quick and dirty troubleshooting.
Oh yeah. Like a portable AV scanner. Yeah.
Exactly.
Yep. ClamAV has a very wide-ranging signature database. It has signatures for a bunch of stuff, including a lot of Windows malware, of course, but also Linux and Macintosh malware. Sure, its signature database is comparable to the other big antivirus companies. It is listed on VirusTotal. You can, if you look up something on VirusTotal, you can see whether Clam detects it. In my experience, Clam is quite conservative, where some antivirus products might alert on like bad crapware, adware, stuff like that. Clam is less likely to do that in my experience, but it still has like the potentially unwanted application category that it has in. But yeah, it definitely detects a bunch of different operating systems malware. We're running on Linux today, but no matter where you run the scanner, it uses the same database, the same database that comes from Cisco. And that's what I didn't show. I guess we only dealt with our own signatures today, but we can use the built-in signatures. And how many of these samples right here are old, and so I'm betting they're all detected, except maybe that picture of DTOM.
But it should be.
Huh?
But it should be.
But it definitely should be detected. Okay, so this is already giving us some bad stuff. So turns out our picture of DTOM, our signature is effective because it's not in the signature database. There's other stuff in here. This is your document from earlier, right? Yeah, it is. This thing is in the Clam database, as you mentioned. And this guy, my signature for our unpacked file appears to be okay. But yeah, so this is using just running it open with the provided signatures. But the utility in this case is if you've got a new piece of malware that's less than two or so weeks old or something, a week or two, and it's not being detected already, or if it's
pulled out for real life things. It was cousin Jim had a problem with his laptop, so he shut it down, left it on the shelf, and I finally heard about it a month later. So yeah, by then it's up. Yeah,
for sure. Yeah, and Clam is really nice. It works on Linux and it updates the definitions are updated hourly. I don't know. They push updates all the time, just like all the other AV vendors. It's no worse than other AVs in terms of its detection range. Its like effectiveness, the amount of stuff that it detects. So yeah, it's really good. It's really good to use as a portable virus scanner for sure. Yeah, it's also really interesting to see how it's written. If you're ever curious how an antivirus engine is written and how it works. Like how it does what it does, like all of the decompression stuff that it does, all of the like code simulation stuff that it does. Windows Defender does a bunch of cool stuff too. Because what could be better than like a multi-architecture CPU simulator that runs as admin on your box and scans only malware? Anyway, excuse me, I have a cold. Any other questions, comments, concerns, curiosities? Later, nerds. Did anyone find this interesting?